This is section 8.4, part A, vectors in three-dimensional space. Your I can statements: I can express algebraically and operate with vectors in space. The Cartesian plane is a two-dimensional coordinate system made up of the x and y axes that allows you to identify and locate points in a plane. To represent points in space, you need to use a three-dimensional coordinate system. The third axis that needs to be added is the z-axis that passes through the origin and is perpendicular to both the x and the y axes. The additional axis divides the space into 8 regions that are called octants. A point in space is represented by an ordered triple of real numbers x, y, and z. The distance between 2 points, when the points are 3 dimensions, you just need to add on to your distance formula. So it is normal distance formula in 2 dimensions is the square root of x2 minus x1 squared plus y2 minus y1 squared. In 3 dimensions, you just need to add plus z squared minus z2 minus z1 squared, and you will have the distance. Midpoint formula in 2 dimensions is x1 plus x2 divided by 2 and y1 plus y2 divided by 2, because you're just finding the average of your x coordinates and the average of your y coordinates. When you get into 3 dimensions, you're just going to have to add the average of the z coordinates, so you do need to add z sub 1 plus z sub 2 divided by 2. A tour of the Sierra Madre Mountains lets guests experience nature by ziplining from one platform to another over the scenic surroundings. 2 platforms that are connected by a zip line are represented by the coordinates of 10, 12, and 50, and 70, 92, and 30, where the coordinates are given in feet. We need to find the length of the zip line needed to connect the 2 platforms. So when you're finding length, your first ordered pair or ordered triple is x sub 1, y sub 1, and z sub 1. The other one is x sub 2, y sub 2, and z sub 2. So we plug that into our distance formula. In this case, it's going to give us 70 minus 10 squared, 92 minus 12 squared, and 30 minus 50 squared. And all together, that'll give us a distance of approximately 101.98 feet. So they'll need about 102 feet of zip line to reach between those 2 points. An additional platform is to be built halfway between the existing platforms. Find the coordinates of the new platform. Now remember, when you're finding midpoint, we use x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So this is going to give us 10 plus 70 divided by 2, 12 plus 92 divided by 2, and 50 plus 30 divided by 2. 10 plus 70 gives us 80. 80 divided by 2 is 40. 12 plus 92 gives us 104. 104 divided by 2 is 52. And 50 plus 30 is 80. 80 divided by 2 is 40. So if they want to put another platform that's exactly halfway between those, it should be located at the coordinates of 40, 52, and 40. To find the component form and magnitude of AB that has the initial points of A at -4, -2, 1, and the terminal point at 3, 6, and -6. And then we need to find a unit vector in the same direction of AB. Now remember, when we found the component form, we did x sub 2 minus x sub 1. Y sub 2 minus y sub 1. Since we do have a third point now, it's going to have to be z sub 2 minus z sub 1. So we're going to do 3 minus -4, 6 minus -2, and negative 6 minus 1. So this is going to give us 7, 8, and negative 7. To find the magnitude of this vector, so let's call this vector AB. To find the magnitude of vector AB, it was the square root of a squared plus b squared, but since we have that third point, we're going to have to add c squared. So this is going to give us 7 squared plus 8 squared plus negative 7 squared. So the magnitude of vector AB is going to be square root of 49 plus 64 plus 49, or radical 162. If we write that as a decimal, it's going to be approximately 12.73. And remember, to write this as a unit vector, it's going to be 1 over the magnitude of your vector times the vector itself. So in our case, we're going to do 1 over radical 162 times 7, 8, and negative 7. When you multiply, this is going to be 7 over radical 162. But remember, you cannot leave a radical in the denominator, so we're going to move the radical to the top, leave the number on the bottom. On the next one would be 8 radical 162 over 162, and negative 7 radical 162 over 162. So this would be the unit vector for this vector. Remember, a unit vector is a vector that starts at the origin, has the same direction as the original vector, but has a length of only 1.